Hello, it's Miss Linsizen. I am bringing you this acceleration notes. So it's really short. The notes are short. And then we're going to do a couple of the a couple of the problems at the end. Let's get started. So acceleration is the rate at which an object changes its velocity. So acceleration is a change in velocity, so rate at which the object is changing their velocity. So to calculate acceleration, we're going to use this acceleration formula, which is the change in velocity divided by the change in time. Typically, you will not have to actually calculate the change in time. It'll just be given to you. But to calculate the change in time, you would just use the change formula for time. So speaking of the change formula, we are going to continue what we were doing with change in position, but now instead of calculating change in position, we're going to calculate the change in velocity. So that triangle, the delta, just means change, and the V we're going to use for velocity. So the change in velocity is calculated by taking the final velocity minus the initial velocity. So an object accelerates whenever it changes its velocity. And we know that velocity has the two parts. It has the speed and the direction. So it can either speed up, slow down, or change its direction, which would be turning. So if there's a change in direction or a change in speed, that is acceleration. When you change directions or turn, it matters. Since changing the direction changes your acceleration, then acceleration is a vector, meaning it has both a magnitude and a direction, just like velocity. Turning changes your velocity because it changes the direction. Speeding up or slowing down changes the velocity because it changes the speed, which is the magnitude of velocity. Either way, your velocity is going to change. So you can speed up, slow down, or change direction. So you'll notice on your paper that you have some boxes, and there's a column that's empty. So in that empty column, you're either going to put, for these next six, you're going to, or five, it is six, you're going to put no acceleration or how the acceleration changes. So a box is traveling along a conveyor belt at a constant speed. So if the box is traveling along the conveyor belt at a constant speed, there's no acceleration. So conveyor belt's like what you put your groceries on when you're at the grocery store to send them to the checker, because both the speed and the direction remain constant, so no acceleration. A car traveling along a winding road with a constant speed of 60 miles per hour. So since the road is winding, your car is changing directions. So there is an acceleration in the way that it is accelerating because the direction is changing. A rocket travels straight up at 10,000 kilometers per hour. There's no acceleration because the rocket is moving at a constant speed and not changing directions. Robert runs around the block at an average speed of 8 meters per second. So remember that a block is a square, so each time he changes his direction, even though he might be moving at a constant velocity, he might be moving at a constant speed, his velocity is changing because he's changing his direction. Angela runs on a treadmill at a constant speed of 10 miles per hour. So this is really similar to the conveyor belt. Since her speed is constant and her direction stays the same, there is no acceleration. Catherine is stopped at a red light when the light turns green, she drives off at a speed of limit of 45 miles per hour. So since her speed changes from 0 to 45 miles per hour, there is acceleration because there is a change in speed. All right, so now, and the units for acceleration, so this is important, are meters per second squared. So let's think about that. So if let's say we have a change in velocity of 10 meters per second, so it's sped up 10 meters per second, at positive 10, and that's over 2 seconds. So as we've looked at before, the unit is derived from what you're dividing, what your two variables that you're dividing are from them. So if you look at this, now we've got 5 meters per second each second. So for each second, the velocity of this object is changing positive 5 meters per second each second. So for the shorthand of that, it's meters per second squared. Sometimes you'll see it written as meters per second. Both of them are correct. So just so you know, if you see either one of those. All right, now there's a little box on your note-taking sheet. And this can get a little bit confusing. We will talk a lot more about this if you'll just write it in your notes so you have this in your notes. So you're looking at the two different parts of velocity. And we want to know whether we have a positive acceleration or a negative acceleration. So if we have a positive direction and the object is speeding up, that's positive acceleration. So right across from that, if we have a negative direction, meaning it's going back towards the start and it's speeding up, that is negative acceleration. At the bottom on the left-hand side, if we have a positive direction, but the object is slowing down, that is negative acceleration. And here's the one, and we'll talk a lot more about this later, that's sometimes a little hard to wrap your head around. If we have an object that's moving in a negative direction and it's slowing down, that's a positive acceleration. So I want you to kind of think about this. Sorry, my pen decided not to work. Oh no. So if we have a negative direction and the object slowing down, two negatives. Positive, slowing down, negative. Negative, positive. Positive, positive. So you really have to kind of think about it like a multiplication problem. And what happens if you have two positives, you multiply two positives, or a positive and a negative, or a positive and a negative, or a negative and a negative. So if you think about it mathematically, it helps. And we'll go, like I said, we'll go over that again later. All right, so now let's use a formula to calculate acceleration. So we still have three things. We have acceleration, we have the change in velocity, and we have the time. So our formula for acceleration is change in velocity divided by time. So for this one, we know that the change in velocity was negative 14 minus 0, and the time was 2 seconds. And some of these you can just do in your head. Obviously, if it's got a 0, you can do that in your head. So you're going to take your change of velocity, your 14 meters of your final, minus your 0 meters of your initial, divided by the 2 seconds in which this change occurred. And that's going to give us a positive acceleration of 2 meters per second squared. So that's it. They're really not that much more complicated than anything else that we've done. Still really three variables. All right, a bicycle rider increases his speed from 5 meters per second. Just a second. From 5 meters per second to 15 meters per second, and this change occurs in 10 seconds. So what is their acceleration? So we've got 15 is our final, 5 is our initial, and the time in which this occurred is 10 seconds. So acceleration is our change in velocity divided by our time. So 15 minus 5 divided by 10. So that's going to be 10 divided by 10 gives us an acceleration of positive 1 meters per second. So that's it. The rest of these follow along with that pattern. So that's what you're going to do today. Make sure that you finish this video all the way through because there's going to be a question there's questions during it. All right. Have a great day. Thank you.